So here's a look at problem 11. With our knowledge of the rational roots theorem, we should realize that places where this graph crosses at 0, 0 are roots. It looks like here we cross at exactly 3, which means one of our factors should be x minus 3. And we're expecting to see 4 of these guys at some point. But if we look at this one, and we look up at our equation that our classmate is looking at, there's no way that 5 has 3 or negative 3 as a factor. So that is an argument that this is incorrect. The other number is somewhat irrelevant. I suppose it could be some irrational number thrown in there. But because this negative 3 number is obviously one of the roots on the graph, it certainly does not match with the equation. The rational roots theorem again says that all factors of this last value divided by all factors of the leading coefficient, which in our case is 1, those are the only possible roots for this equation. So it's either 1 over 1 positive or negative, or 5 over 1. There are only 4 possible roots here. So that's an argument against matching this particular graph with the given equation in 11. Likewise, number 12, since we're there, if we are looking for a hole in the graph, that means there are matching factors both above and below. So a hole, if it's at 4, there must be 2 factors that are x minus 4 that would cancel, quote unquote, as we're looking at the graph. Other parts we could add in actually what we please, just to make it a bit more involved as a rational function. We could have just gotten away with, I suppose, here to meet that single requirement, x minus 4. Then our problem says, write an equation that has a vertical asymptote at negative 4. So answer for part 2 of this same question is, if it has a vertical asymptote at x equals negative 4, it has a factor on the bottom of x minus 4. Beyond that, we can add something else if we would like to the top and or the bottom. That's completely up to you. But the minimum requirement there is having x minus 4.